Hi, it's Joshua coming to you from here in Abbotsford, British Columbia. It's December the 12th, and for all you out there who's keeping ahead of the star stove here, I've just drawn up a simple sketch using GIMP. And what you can see is a pot sitting on top of two iron plates, and as I come closer here, you can actually see where the air is coming in through the water plenum, and then it's coming inside the plenum and going through the top of the 4-inch pipe and traveling to the bottom and then going back up. Then you can also see where the propane goes into the bottom. So that's a quick rendering here of how the air and the fuel combine, where it goes up and it hits a little swirl device here. I don't know if you can see it or not. A little point in the center, and the blue line here, that's actually the flame that's produced when you pull your flame back in to produce your level 3. Then you can bump up the the volume of air to produce your level 3, and that creates a very high intense flame, much more than what you would normally get out of any kind of torch. And even on the 16-inch plate, it'd probably get like a mild red in color. Both the top plate and the lower plates are kind of gray color. I should have made them orange or something like that so that they would stand out. But anyway, what you have is your hexagonal plenum. It might be a round water plenum, and then you take your two plates, where the bottom plate is made into an air plenum, and you just suspend it to where the heat is kind of going about a little up above the halfway point of the water plenum. And your water plenum in this case will probably be about a 20 inches across. You can make it say 8 inches deep and maybe 4 or 5 inches wide. There'll probably be around about 10 gallons of water. And but in this setup here, it's going to heat the water up very fast, because you're going to have a circumference of flame, at least a 16-inch circumference of flame, which is a lot of flame. That would be about 48 inches of flame. Surf is actually heating up the inside of the water plenum. That's quite a bit. And I know it works on two 12-inch plates. The 16, I'm fairly certain that the flame is going to extend beyond. It might be a little more finicky, because the bigger that you make the pipe, or longer you make the pipe or the plates, that it increases the vacuum potential that actually makes the flame tricky to kind of pop in, because it's vacuum sensitive. And at the same time that you're able to put a big military pot to heat your soup or your stew, and at the same time you're also heating your hot water to doing the dishes. So this is the heart of the star stove, and I'd like to give you a quick peek. You can see where I've made the computer drawing here. That's the hand drawing that I just did up, and this bottom part is beginnings of a volatilizer unit, using by spinning the flame in the same way as in the star stove. And you can see where the exhaust goes into is captured by the exhaust plenum. And I'm not sure where I'm going to put the syngas, or report the syngas, probably down toward the bottom there. And to the left you would have like a joepipe fuel processor. The way I've designed this is that you could actually have 3 processors operating independently or all at the same time. So it's going to be a little work to get this all together. Just the mechanics of it. The theory is easy, but when it comes to actually fabricating the parts and making them fit, it does take a little bit. Okay, it's this is 5 minutes. I'm going to end here. I'd like for your comments, but there's enough here information on the star stove for most of you guys out there to build it. And if you want to build one using the 2-plate system, spaced about 1/16 of an inch apart or so, just let me know and I'll walk you through it. This is Joshua out from here in Abbotsford, British Columbia.